Okay, so here's another example dealing with multiple bonds. It looks like now we have a carbon-carbon triple bond. So how do we deal with that? Well, it turns out that there is indeed two different ways of doing this. So again, work left to right, and let's begin at the left. You'll notice you have a CH3. I'll put that down. You're going to have a CH2 followed by another CH2. So let's put that in like that. Now, notice we're going to come to the double bond. So now what we're going to do is put that first carbon right there, preserve the triple bond, there it is, and put the other carbon of the triple bond right next to it. That's going to be followed by a CH2 and a CH3. So that those two atoms will be put in just like that, and you're done. Basically, that's the first way you can actually do this. Now, is there another way? Yes. In that case, what we're going to do is we're going to drop the double bond. We're going to take it out. Again, this is going to make the structure a little bit less clear. However, you're going to have to guess as to, not really guess, but you're going to have to determine that that triple bond is there. And it's not hard to do with some practice. But let's go ahead and go through it. So here's the second way to do this. Let me push this up. We're going to repeat the first part of the molecule, CH3, CH2, CH2. Now the first carbon of the triple bond, we're going to put it there. Now we're going to put the second one, and notice I didn't put the triple bond in. I just have those two carbons side by side. Now, we complete the structure with a CH2 and a CH3. So there you're done. We have done the second type of this problem with a multiple bond. Now, you may be a little confused. You might say, well, if I look at this, how do I re-expand that up into something that we had showed here first? Well, it's really not that hard to do, because a condensed formula must show all hydrogen present. Okay, so a condensed formula has to show that. If you see two carbons next to each other and it doesn't look like there's any hydrogen attached to them, you should know, or you should guess, or you should figure out that that's indeed a triple bond. So let's just re-expand this. So that's CH3. There it is. That's easy because you know exactly how much hydrogen is on that carbon. Now for the CH2, that's also simple, because you know that there's two hydrogens on that carbon, and the same for the CH2 next to it. Whoops, I was down a little bit more.